Hello, I'm Eric Burchert and I will be presenting along with Eva Carmichael and Matthias Finez. I'd like to take a moment to acknowledge that we are recording this presentation in Jabuktuk, a city situated in Micmaci, the ancestral and unceded territory of the Micmac people. This territory is covered by the Treaties of Peace and Friendship, which Micmac, Maliseet, and Passamaquoddy peoples first signed with the British Crown in 1726. This treaty established the rules for what was to be an ongoing relationship between nations. We have researched and will now discuss various aspects concerning the regeneration of the forest cover in Point Pleasant Park, also known as Amnu-Takati, which covers a large swath of land on the southern tip of the Halifax Peninsula. Amnu-Takati means the place of the spirits and was an important Micmac gathering place for many years before the British colonization of Halifax. Point Pleasant Park contains an urban forest which is bordered on three sides by the Atlantic Ocean and the other side by a residential area of Halifax, as well as some shipyards. The history of Point Pleasant as a park goes back to 1866, when it was declared a park and deemed solely fit for recreational purposes and as a wildlife habitat. The park's vegetation up until 2003 could be described as an even-aged, old-growth Acadian forest. In 2003, on September 29th, a Category 2 storm named Hurricane Juan ravaged Halifax and Point Pleasant in particular, destroying 70% of the park's tree canopy. The forest suffered a great deal of damage due to having a lack of younger trees, and young trees would have helped as a wind buffer lower in the tree canopy, and they would have been able to fill gaps left by large trees being felled by the winds. This lack of diversity in tree age in the park was a large factor in the forest's slow recovery.
6 20-meter by 20-meter sites were chosen. The sites were chosen by locating the areas that had their forest structures impacted the most by the hurricane. A measuring tape was used to measure the diameter at breast height of the trees. We used a breast height of 4.5 feet. iNaturalist and field guides were used to identify the species of tree. We did not include any trees that had a BDH of less than 2.5 centimeters. The density of the red spruces and red maples were measured, as well as the total density of trees. The species richness was also measured. The data was analyzed using regression analysis. Regression analysis was used because all graphs were seeking to explore the relationship between two variables and not two means. Normally, these variables were some form of density and time, but in one case it is species richness over time. Figure 2 is a map of where the data sites are located. Notice that the sites are clustered at the southern end. They also tend to be closer to the eastern side than the western side, and most are very close to the shore. That is because the southeast is the most exposed to the ocean where the hurricane originated, so the sites with the most damage naturally congregate there. Figure 3 shows the total density of the tree species over time in Point Pleasant Park. The total density data was collected from the previously mentioned 6 20-meter by 20-meter sites from 2004. This graph was created to assess how well the park is recovering from the 2003 hurricane damage, which lowered the density to near zero. By comparing the 2004 density with more recent densities, we can get a fairly accurate representation of how well the sites have recovered from the hurricane. The graph shows that the total density was increasing fairly linearly, with a R-squared of around 0.5 and a positive slope of about 10. However, it should be noted that the site densities seem to have reached their peaks at approximately 2019, as the majority of sites in 2021 seem to be lower. This suggests that these sites in Point Pleasant Park have recovered from the storm and reached their max tree density. Since these sites were chosen due to having the most extensive hurricane damage, it would seem Point Pleasant Park has either completely recovered or is very close.
Before the 2003 hurricane, the park was a mature, even-aged Acadian forest. Among other species, red spruce trees dominated the landscape, and red maple trees were present scattered throughout the forest. In 2004, the dominant species of tree in Point Pleasant Park was a red spruce, presumably due to its ability to withstand stressful events like the hurricane. To examine the dominant species of tree stands of red spruce and red maple in Point Pleasant Park, the densities of both species were measured at 6 different sites of 400 square meters each between the years of 2004 and 2022. Over time, the average density of red spruce trees in Point Pleasant Park between 2004 and 2022 increased from 3 to 8 trees per 400 square meters. The average density of red maple trees in Point Pleasant Park increased from 0 to 38 per 400 square meters between these years. We can therefore deduce from these trends that the red maple has shown a dramatic increase in its density and has come to dominate the landscape over the course of these last 2 decades.
For the third discussion topic, I'll be talking about how the species richness in Point Pleasant Park has changed over time. To examine the recovery pattern of trees in Point Pleasant Park, species richness was measured at 4 to 6 sites, depending on the year, measuring 400 meters squared each, between 2004 and 2022. Measurements were done once a year, almost every year during this period. The data is only missing information for 2005, 2007, 2016, and 2020. Species richness is a measurement representing the number of different species in a particular area and does not consider how many organisms of each species reside in the area. For this presentation, we are dealing with the species richness of trees specifically. So the species richness is the number of unique tree species found in the study areas of the park. In 2004, the average species richness was 2.5, a very low number due to Hurricane Juan the year before. Over the following 18 years, there was a strong positive linear relationship showing an increase in average species richness almost every year. In our data, species richness reached a peak of 11.6 in 2018 and averaged out to 10.1 over the following 3 years. This indicates that the species richness in the park may be plateauing. For the entire dataset of species richness measurements, the R-squared value was determined to be 0.66. Which indicates 66% of the variability observed in species richness is explained by the regression model. It would likely be great for the park to have its species richness keep increasing. However, the last 3 years of stagnation lead me to believe species richness has reached its peak in Point Pleasant.
Based on the trends in the collected data, we predict that Point Pleasant Forest is still at an early stage in its succession. We know that the canopy was dominated by red spruce before the hurricane, and, as of 2022, the dominant species was a red maple. This tells us that the forest has not returned to its original state of a mature Acadian forest. Because Point Pleasant Park is an urban park, this affects its succession. Firstly, there are management plans in place to ensure that the forest grows back to its original state as an Acadian forest that the public can enjoy. These management actions include removing invasive species, planting native species, and weeding and tending to these native species to promote their growth. Being an urban park also means that it is open to the public and thus to potential disturbances such as vandalism, arson, and trampling. As seen in class, it can be beneficial to consider multiple perspectives to broaden our knowledge of ecology. Incorporating the principle of two-eyed seeing, we can stand to learn a lot from this traditional knowledge of First Nations. For example, indigenous forest-dwelling communities manage tropical forests of Brazil by tending to seedlings and managing with a long-term perspective with future generations in mind. I think that we can implement these practices to Point Pleasant Park as well.
Special thanks to Dr. Allison Smith, who compiled the data and made the graphs, our TA, Nev, who answered all our questions, and the previous students of introductory ecology who went to the sites and collected the data that we used.